Welcome to my channel Adhyan with Flow. Now let's start with our mechanism of breathing. First we have to start inspiration, not inspiration. Alright. In inspiration what we do? In inspiration mechanism what we do? We intake oxygen from surrounding. Why we take only oxygen? Because our RBC bind with oxygen as well as CO2. Okay. Now oxygen comes for atmosphere and passes into our nostrils. Yes or no? Yes. How oxygen is passes into our nostrils? Because at atmosphere oxygen level is high. Oxygen level is high, so we know that molecules, gases can move to their high concentration to their low concentration. This first step is clear or not? This first step is clear? Yes. Now nostrils passes their oxygen towards nasal cavity. Nasal cavity. Now how oxygen will move towards nasal cavity? Because now oxygen in nostrils, they are in their high concentration, and now they move towards their low concentration of oxygen because they have less oxygen and nostrils have high oxygen. In this case atmosphere have high oxygen rate and nostrils have less oxygen rate. Understand guys? Now through the nasal cavity oxygen passes towards where? Pharynx or trachea. Now oxygen enter into trachea. How? Because at that time oxygen level is high in nasal cavity and oxygen moves towards their high concentration to lower concentration and they enter into trachea. So oxygen occurring in trachea and trachea got expand because after intaking gases little bit trachea swollen and now trachea passes their oxygen towards, it may be bronchi. So trachea passes their oxygen towards bronchus and bronchi because oxygen now high in number is there, and now oxygen travels to their high concentration to their low concentration because of their dividing. Because trachea, this is the trachea, and they divided into primary, into secondary, into tertiary. So bronchi is divided into further bronchioles and make bronchioles. So bronchioles got expand after taking oxygen, and bronchioles passes their oxygen. Here is conducting is thing. Here this one conducting nostrils, this phase zone is conducting zone, this zone is conducting zone, and now they move their oxygen towards alveoli, and alveoli is a sac-like structure. After taking oxygen they get expand and now they transfer their oxygen towards blood vessels. Now this is the blood vessels and oxygen come. So this whole mechanism is inspiration after taking oxygen. But this is not easy process. This is not an easy process guys, because after reaching air towards the alveoli they cause pressure. Look at here, after reaching air they produce pressure. Where? They do pressure on our lungs. So our lungs got expanded. I'm writing here, lungs got expanded, and our lungs put some pressures on our rib cage. So rib cage extend. This is pressure. They produce pressure on our diaphragm. So diaphragm got flattened. So this is the whole mechanism. Look at here. This is the diaphragm. This is the diaphragm's muscle. They got straight. They got, this is now curvature form, and after reaching air they got pressure and they got flattened. So this is the whole mechanism of inspiration, inhalation. Look at here, diaphragm contract because this muscles they push, and this diaphragm flat. So muscles before pushing in this diameter and after pushing they less in their diameter. Clear guys? Volume of thorax is increased after entering air in lungs. Rings and sternum raised because expand. We can feel if we inspire, if we inhale, our lungs, our chest cavity is increased. Assume if we inhale, take inhalation and feel our chest size, they expand, and after expel, after removing air, our lungs contract, our chest down. Okay. Now next process is expiration, means exhalation. I'm writing here, This process I am writing here. So diaphragm give pressure on lungs. So lungs pressure on alveoli. Look at here. I'm writing here. Diaphragm puts some pressure on lungs membrane, and lungs produce pressure on alveoli. Alveoli take CO2 and put pressure on bronchioles. Bronchioles take CO2 and put pressure on where? Bronchis. We can also say bronchus. And these bronchus take CO2 and give pressure to for trachea. Trachea gives pressure on nasal cavity. They contain CO2. Nasal give pressure towards nostrils, and nostrils remove CO2. So at a time, O2 in, and this process continue and CO2 out at the same time. So this is the expiration, guys. So that's all about your mechanism of breathing. Whatever I teach you here, already written here. They use some modified words, but don't be panic and don't be confused. Okay, you are familiar with this. You are familiar with everyone. You know now what is sternum, where ribs are connect. Okay, ribs are connect. Here is one lungs, here is another lung. You know everything, guys. Right now you know everything. You know everything. What is this? This is, what is this? These are vertebra, guys. These are our thoracic vertebra. These are our thoracic vertebra. And what is this? These are ribs cage. They covered like this. Look at here. Front part is connected with sternum and posterior part, dorsal part is connected with vertebra. We all know that. We will discuss in our skeleton system. We previously discussed about this, that ribs anterior part, front part is connected with sternum and posterior part is connected with our spinal cord, thoracic vertebra. Okay, look like this. This is the sternum part, and here in back side they are attached with our vertebral column and center part, whereas lungs are located. The center part connected with sternum and back side they are connected with our vertebra, backbone, spinal cord. Okay, guys. So this is all about your inhalation and exhalation. I'll explain everything. Now, what is tidal volume? There are some volume, not too much important, but yes, important. This volume is important. So this is important for question. Not highest important, but yes, important. What is tidal volume? TV. Volume of air inspired or expired during a normal respiration. This is a normal respiration. How much amount we take inside and how much amount we expired. This is the tidal volume. Okay, it is approx 500 ml. A healthy man can inspire or expire approximately 6,000 to 8,000 ml of air per minute. This ratio you should remember. What is inspiratory reserve volume? If we inspire forcefully, we can inspire normally, and if we inhale extra air, forcefully air, this call it as a inspiratory reserve volume, IRV. If we forcefully inhale the air, and expiratory reserve volume if we forcefully expire, if we forcefully exhale. This is the volume of forcefully inhalation, this is the volume of forcefully exhalation. You have to remember this thing. Now what is the now residual volume, RV, after expire, after exhale forcefully, after expire forcefully, still some air remain in our lungs. After expire forcefully, after exhale forcefully, there are some air remaining in lungs. The volume is there this much. Now inspiratory capacity, what is the IC? This is the normal, means if we normally exhale, and then hand to hand inspire, if we normally exhale and hand to hand inspire, this volume is inspiratory. And what is expiratory capacity? This is the volume if we normal inspire, take a breath normal, and then remove, expire some air. This is the volume of expiratory type. What is the functional residual capacity? Volume of air that will remain in the lungs after normal expiration. This is the formula you have to remember. What is vital capacity? The maximum volume of air a person can breathe. Maximum volume a person can breathe in after forced expiration. After forced expiration, maximum amount that person can inhale. This volume is vital volume. Now total lung capacity. Add some values. Add vital capacity, residual volume, and you got total lung capacity. Here is next exchanges of gases. How they exchange? Where is diagram? Yes, here is your diagram. We know that this is the alveoli part, This is the our alveoli part. Our alveoli have less oxygen, but if we inspire, if we inhale, then alveoli rich in oxygen. So here high amount of oxygen. Then alveoli transport oxygen towards the blood vessels, and oxygenated blood carried by pulmonary vein. Pulmonary vein transport oxygenated blood in atrium, left atrium, and then left atrium passes their oxygenated blood towards the left ventricle. Then left ventricle connected with aorta, they supply oxygenated blood to all the body. How? Because body tissues have less oxygen, but this artery have lots of oxygen. This artery have lots of oxygen and tissue have less oxygen, so oxygen can move to their high concentration to their low concentration. Now what happened next? Lots of CO2 contained by body tissue. They release their CO2 into vena cava, veins, and veins carry deoxygenated means CO2 blood. They reach towards the right atrium. Right atrium valve open, and this whole CO2 blood enters into right ventricle. And right ventricle connected with pulmonary artery, they supply CO2 plus blood towards the lungs, and they face alveoli and they release their CO2 into alveoli. So CO2 get high and they release. So this is the whole mechanism how CO2 in transferred to the alveoli. Alveoli transferred oxygen towards the pulmonary vein. Pulmonary transferred oxygen to, so oxygen taken by left atrium, and this left atrium passes their oxygenated blood into left ventricle. Left ventricle passes into their oxygenated blood into arteries, means aorta, and aorta pass oxygenated blood towards the body tissues. Tissues passes their CO2 into the blood vein, and blood vein goes towards right atrium. Right atrium passes their blood, CO2 blood towards right ventricle. Right ventricle passes CO2 blood into the pulmonary artery. Pulmonary artery passes CO2 into alveoli. Alveoli passes CO2 into bronchioles, bronchi, trachea, and throughout, out from nostrils, CO2 out and oxygen in. This is the whole mechanism of exchanges of gases. So whatever I teach here, already these things are written in here. So that's all for now. We will meet in our next video. So thank you for listening me. And if you are not subscribed my channel Adhyan with Flow, then please subscribe. And thank you for listening me. Keep smiling and keep revising. Thank you.